Here we go. We have a question, allocate minimum pages. So you have given an array of integer where each element represents the number of pages in the ith book. You also have an integer k representing the number of students. Our task is to allocate books to each student such that each student receive at least one book. Each student is assigned a contiguous sequence of books. No book is assigned to more than one student, and our objective is to minimum the maximum number of pages assigned to any student. In other words, out of all possible allocations, we need to find the arrangement where the student who receive the most pages still have smallest possible maximum. So find we need to minimize the maximum number of pages, and we need to return -1 if a valid arrangement is not possible. So we have given this example. In this, we have divided into these portions. So there are these possibilities. If we have only two students, so first student will read first book, second student will read other books. So the summation, the maximum value is either 12 or this. So the maximum among these is this value. So this is one allocation. The next allocation can be first person will read two books, second person will read other two books. And in this summation of this and this, and the maximum of this and this is 157. The third allocation can be first person will read three books, second person will read only one book. So the maximum we got is 131. So we got three different allocations, and between these three allocations we need to find the minimum. So the minimum of these cases is 113, which is selected as the output. So this is the answer. And let's suppose we have only three books, but students is more than three. Students is more than length, the array length. So each person will take at least one book, and we cannot allocate a single book to two different students. So in this, allocation is not possible, so we need to return -1 if k is students is greater than books. In this case it is possible. The answer is this. Now in this case there's only one student, so only single student will read all three books, so that's why the answer is 112. Now let's build the approach. I have taken this test case. So the first allocation can be this, the next allocation can be this, and third allocation can be this. So we have only two students, so we divide it into two different portions. If we have three students, we divide into three portions. So it depends on the students. So the brute force will be to divide the array or divide each portion into k number of k times, and after finding all the sub arrays, we need to find the maximum among this allocation and all the different allocation, and at the end we need to find the minimum of them. In one allocation we need to find maximum value, so the maximum is this. In this allocation we need to find a maximum value, maximum is this. In this, maximum is this, and after finding the maximum we need to find the minimum value. So I think minimum answer is this. If we divide into 2 and 2 portion, uh, no, the minimum is this, so this is smaller, the answer is this allocation. So we need to find this. So we need to find the minimum the minimum after finding the maximum. So the brute force will be n log k, but we can optimize it using binary search. How we gonna apply binary search? Each person will take at least one book, either this book, this book, this book, or this book. So the minimum, the minimum is either this, or this. So our lower bound is 90. Why 90? Because at at least we can allocate one book to each one book to uh, each individual person. So this person has 12 pages, this person has 34 pages, this person has 67 pages, this person have 90 pages. So at max we go to 90. So no matter what the case, 90 is our lower bound. 90 is our lower bound. If we uh, if we give one book to each individual student, and what's the higher bound? Higher bound, let's suppose we give every book to only a single student. So higher bound will be summation of all these values. So let me find the higher bound. So the higher bound is 203. So this is the summation. Now let's find the middle value. What is the middle value? It is the summation of this value plus lower divided by 2. So we got 146. So if we want to allocate 146 pages at max to one single person, then how many person do we require? So first person, our answer is 1. We have a solution. We have a separate function. As we solved the question previously, yesterday. So we have a single person, and single person till yet have not read any book. Then it will read this book 12. Then it will read second book. Then the summation is 46. Then it will read third book. So the summation is 113. So it is still less than the maximum. It is less than the required. Then if the single person, the first person will read, he wants to read the fourth book also. So then we go 203, which exceeds our maximum number of books that we can allocate to one single person. So he cannot read the fourth book, he cannot read this book. We need one more person to read this book. We need one more person. So answer is 2. And the second person will read 90. He will read this book which contains 90 pages, and one person at max can read 146 pages. He cannot read more pages. So we have traversed in the array. Then what we got? We got two persons. If we allocate at max 146 pages to one person, then we require two persons. So this is a valid answer. So if we allocate 146 pages at max to one single person, then we require two persons. So this is a valid answer. So answer can be 146 or can be smaller than this value, So now R will be 143. Then 146, so it's 145, my mistake. Then the middle value is 145 plus 90 divides to it is 1 and 7. Then first person, now let's again start first person. We got 12. This is our first person. He is reading a book. First he got 12, then he got 12 plus 34, we got 46. Yes, he can read this book. Then again we got 67, so it is 113. He can read this book. Okay, totally fine. And then we got 90, so we got 203. Now first person cannot read the current book. So we need one more person. Then he will read the current book. So the current person have read 90 pages till now. So now we have traversed into this array. How many persons do we need? How many persons do we need to read 117 pages at max? So we require two persons. So two persons is our required answer. So this is the answer, or the answer can be lower than this value. So we got 116. Then what's the middle value? 116 plus 90 divides 2, we got 103. Now again start. This is the first person. He is reading a book. We got 12 pages. Then 12 plus 34, we got 46. He can read this book. Totally fine. Then 67, we got 113. Now first person cannot read the current book. We need one more person to read, to give this to give this book. We need one more person, because an individual person can only read 103 pages at max. So we require one more person, and he read this book. So this book contains 67 pages, so he read 67 pages. Then 67 plus 90, we got 157. But he cannot read this book. He can read at max 103 pages, but he is reading 157 pages. So we require one more person. So this is not the answer. So the third person will read this book. Then that's it. If we allocate 103 pages to one person, then how many persons do we need? We need three persons, but we don't have three students. We only have two students. So three is not the correct answer. We need we need to increment. We need to allocate more pages to one single person. So how do we allocate more pages to one single person? By incrementing, by updating our L. So we'll update our L to 104. So mid is not the correct answer. So now what's the logic? If required persons, so persons, if required persons is more than k, so we require three persons to read 103 pages. So this is not the correct answer. We need more number of pages to one single person, so that we can allocate books. So this, else we can allocate a book. So either mid be our answer, or the answer can be lower than mid value. So mid minus 1. Now let's do one more iteration. We got 104 plus 116 divides 2 is equal to 110. How many students do we need? So 110. Student is 1 and he is reading a book. First we got 12, then we got 34, so we got 46 in total. Then he will again try to read the next book, but we got 113, so he cannot read. We need one more person, so we got 67 plus 67 plus 90, we got 157. So still we require 3 person and third person will read this book. So if we try to allocate 110 pages to one single person, we require 3 persons to read all these books. But 3 is not the correct answer. So let's give more pages to one single person by updating our L. So 111 plus 116 we got divides 2, we got 1 and 3. So 113. Then let's find out first person. We got 12 plus 34, we got 46. Then we got 67, means 113. Yes, he can read this book. He can read this book. Next, 90. For 90, we need one more person. So to read 113 pages, we require 2 persons. So this is our correct answer. So 113 is our correct answer, or the answer is lower than this value. So 11 and 2, mid minus 1, 1 and 2. Then for 1 and 2, I think we got three students, but 3 is not the correct answer. So then it will be 1 1. Actually, yeah. So we have this 110, 112. Then the middle value is 111. To read 111 books, we require 3 persons. So this is not the correct answer. Then we need to update to mid plus 1. So it will be 1 and 2. Then the middle value is 1 and 2. How many persons do we need to read this book? So we require 3 persons. You can calculate it, but I know that we require 3 persons because for third book we are reaching 1 and 3 point. So we require 3 persons. Then we update 1 and 3. So now L is not smaller than or equal to R. The maximum we can have is this 1 and 3. So actually this is the minimum. So that's what we need to find. So let's check out. Yeah. So we got 1 and 3. So this is the correct answer. Now let's code this. If the students is more than books, so we cannot allocate one book to more than one student. So the answer is -1. Then we got we are finding maximum and summation. Lower lower bound will be maximum of all the books. Then the higher bound will be summation of all the books. Means we are allocating every book to only one student. So that's our higher bound. We go to this. Then we are finding our middle point. Person, how many person do we require if we allocate that many pages to one single person? So let's find out. We have first student and he is reading a book. He have read this book. If it is exceeding the maximum pages he can read, so we require one more person and he will read the current book. Then if the person required is more than the um, the person we have the persons we have, so it means that the books we allocated is not the answer. We need to give more pages to one person. So we need to give more pages. Else this is the correct answer, or we can reduce our higher bound. And at the end, just return the answer. Now let's submit this. And now let's talk about time and space complexity. We got binary search. Binary search, before that we got n, but a binary search and this person is more than this for loop. So now let's talk about this, the higher bound. Binary search will take log n, but in this case n is our summation. So log of summation, and inside of this we have this function. So this function will take n. So the time complexity is n log summation, and space is constant. Now let's find out. We got n log n. Although this is not the not the expected time complexity, but we have solved this question. Code is given in the description box. If you guys have any doubt, feel free to ask in the comment section. And thank you all for watching.